Okay, welcome everyone to the Arena Zone. And this is the fourth attempt of me recording my voice. This time with a twist, because I didn't record yesterday night. So I thought I would record today morning to see how my voice behaves without any preparation. I woke up like 15 minutes ago. I just did my morning routine and now I'm here. I want to see how my voice is when I don't have any preparations after waking up. So yeah, we'll be doing Hexcells today. Hopefully that helps. We're gonna do Worlds 3 and 4 now. So yeah, let's see if we can keep going on a good way. Okay, so here's the first difference you'll notice between the last episode. We have numbers outside of this house. It's like this 0, this 3, this 2, this other 3, and this other 0. What does this mean? This means that, for example, in this line here, we have 3 blue cells. So if we have a total of 3 yellow cells to be marked and there are 3 cells in this column, it means we need to have 3 blue cells total. So these 3 blue cells need to be here. Same's true for this 2 column. Since there are only 2 to be filled, they have to be blue to satisfy the 2. And we can right click them. We can right click them to make them visible or invisible. Well, not invisible, but faded out. So that we don't lose track of, oh, have I completed this before? Have I not completed this before? And yeah. Moving on, we have this 3 here that needs to be completed with this blue cell. And this is the left part done. For this on the right, we have a column of 0. So there are 0 blue cells in this column, which means this has to be black. And the same is true for this column of 0. This has to be black. For this column right here needs to be 3 blues, but we have 5 cells total, so we can't just take a guess, because that's not good. So let's begin with the zeros that we just uncovered. Because they are zeros, all adjacent cells need to be black. So we're gonna mark that. And we uncover another 0, so the next adjacent cells are all black. Now here, we have the 3 column that now only has 3 to be filled. So we're gonna fill those. And bam! Now this 3 column is satisfied. And for the last, we have one cell remaining to be marked. And this is gonna satisfy both the 1 and the 2. Pretty interesting, right? Let's move on. Oh, new things. When we have a brackets on the number, could be a column, could be a diagonal, could be a number inside a cell, it means that all blue cells in that position need to be consecutive. Just like instructed here, number side brackets tells you that blue cells are consecutive. So, for this case, for this column doesn't matter much because there are only 2 to be filled here. So it's gonna be those 2. But now for this column right here, it means that they have to be consecutive. So it couldn't be like this cell right here, the top one, and the bottom one, because they wouldn't be glued together. They have to be glued together to be consecutive. So if it can't be both the top and the bottom, it means that it has to be the middle, because there are only 3 cells here. That's a common pattern for a consecutive 2. Whenever you have 3 cells in a consecutive 2, only 3 cells in a consecutive 2, it means that middle cell is always true. It's always blue, actually. The same is true for this column right here. And now we need to use this tree to complete the left side, because this tree is already satisfied, so the rest of the cells adjacent to it have to be black. And now to satisfy both these twos, the top cells need to be blue. There you go. Completed. Now we can follow the same pattern for this for right here. So since there can only be consecutive, there can only be two ways to fill this column. Either being the top 4 or the bottom 4. Because the only cells missing could be the top one and the bottom one. Or the bottom one. Can be both at the same time, because there will only be 3 cells left to be filled. And it can't be both blue at the same time, because otherwise there would be a disconnect between the blue cells. So these 3 have to be blue. Now we can't yet figure out whether this 4 is completed on the top or on the bottom. But we can use this 2 right here to see that it is satisfied. So the rest of the adjacent cells are black. And now we can complete the 4. With the help of this one, because this one's satisfied, so any leftover cells are black. And now we can complete the 4 because it needs to have 4 blues. And the only way to do that is with this being blue. There you go. Completed the 4 column. Now this one right here needs a blue cell, so that has to be blue. And this one right here tells me that this cell is black because this one is already satisfied. So this is black. Now for this 2 column we have to complete it. Only 2 cells available to complete it. Both need to be blue. And now for the right side, we have a 3 column that are consecutive. So when we figure out this one, because we'll have to figure out the 3, because this one needs to have a blue adjacent to it. So since there's only 1 cell adjacent to it, it has to be blue. And now this consecutive 3 needs to have all 3 cells glued together. But here's the trick. They can be separated by a gap. This gap can be a physical gap in the cells, but it cannot be a cell between the other cells. Or for example, this is considered consecutive. But if we were to not have this cell here be blue, it wouldn't be consecutive. I will explain this better later, but for now, know that in a column or diagonal, because these numbers here can be diagonal, a gap between the cells that is not made by another cell can be considered consecutive. The rest of this column is completed. This 3 is satisfied, so the rest of these have to be black. Next one. So the same as cells marked zeros, we start with the columns marked as 0, because they're the easiest one to complete. This column needs to be empty. Now I have the 0 here that needs to be empty. This one requires this to be blue, completing this other one. So this is black. And to satisfy this column of 1, this has to be blue. Now, here's another thing you can use. For this 2 columns, since we can know in advance whether which cells will be blue, we can use these ones as support. For example, if this cell right here were to be blue, it wouldn't be possible to complete the 2 or the 1. Because if this was blue, this would have to be black because of the 1 right next to it, right next to them. But since the blues need to be consecutive in this column of 2, this would be illegal. Since this being blue and this being black would separate the other blue from this blue. So this cannot be blue, making this one have to be blue because of this one right here. Since they are they are consecutive in this column of 2, the next one has to be blue. And now this column is complete. So we mark this as black. Next, for this tree right here, it needs to be completed, and the only possibility is with all the adjacent cells being blue. And now we have the 4 column that needs to be consecutive, so 1, 2, 3, 4. There you go, easy peasy. The rest are black. And now this one has to be black because of the 0, this one has to be black because of the other 0, and now all 3 of these need to be blue to satisfy the column of 3. We can start from this 3, but also from this 2, that both tell me that this cell right here has to be blue, satisfying the column of 1 and the cell of 1. Next, for this column of 2, we can figure out that both of these remaining cells have to be blue to satisfy the 2 completely. And now we can do something here to figure out this column of 3. For example, if this cell was to be blue, or is it this cell were to be blue? I don't know, English is kind of weird sometimes. Because it's singular, so I guess it should be was. If this cell was to be blue, it wouldn't be possible to complete the consecutive 3 column. Because this would need to be black, this is blue, this is black, because of the 2 right here, it would be completed. But then, how would we complete the 3 in column? Because we could get the consecutive of these 2 right here, but since this one would be black, it wouldn't have been consecutive, so this cannot be blue, this cannot be black, so they are the opposite. And now to have 3 consecutive here, we need to have all these here. Completing the column 3, marking this as black. Now, this one right here is completed, so we mark this as black. And finally, to complete this 3 column, we mark all 3 of these as blue. There you go. New thing, a number inside dashes tells you that the blue cells are not consecutive. Holy shit, my voice. Let's drink some water. Fresh water? Okay, so what does it mean for the cells to not be consecutive? For example, this column right here. If the cells are not consecutive, it means they can't be together. For example, we couldn't have these 2 be connected, and we couldn't have these 2 be connected. So what does this mean is that for a grand total of 3 cells, they need to be separated and be 2 cells, so the only possible solution is this. I hope this makes a little sense, but I'll explain it better as the time comes forward. So this 2 column is complete. This cell of 2 is complete, so we mark the adjacents as black, rather. And now to complete both of these 2's, we need this cell to be blue. Okay, now let's see what's next. Well, we should have started with the 0 rather, but I had to explain the dash. So all these are black. To complete this 2 right here, we need these 2 to be blue. To complete this 2 right here, we need these 2 to be blue. This is an easily mirrored situation. Now to complete this one right here, it needs to have 2 consecutive blues. So since one blue is here, the other one has to be this one. Otherwise it wouldn't be happy as consecutive. They have to be stuck together, making the rest of this column black. Now we have this 2 right here, which means that both of the adjacents are blue. And we have the 0 right here, which means both the adjacents are black. Now we have this 2 column right here, which is completed as per both these blues. For the rest of the column is black. The same for this 2 right here. Now this is still mirrored inside of this donut. So both of these 2's are completed, which means these are black, and these zeros means that these are black. Now for both of these 2 columns, we have these ones, auxiliary one here, meaning that this is blue and this is blue, completing both of these columns. The rest of the columns, column cells are black, and they are completed. Now both of these ones tell me that they are completed, so the other adjacent cells are black. And now the next cells have to be blue, because it's the only way to complete the ones. And now for this one right here, it is completed. The column is completed because it has one blue already. But the rest of these have to be black. We have a 0 right here, so we're gonna use that. To complete this 2 right here, we need this to be blue. And to complete this one right here, we need this to be blue, completing this other one and marking this as black. Now, for this situation right here, we have 2 2's that need to be completed, and the 2 possibilities would be either this is blue and this is blue, because if this is blue, this 2 tell me that this is black. So this would have to be blue to complete this 2, or this middle cell right here is blue. And since only one of these possibilities completes this column of 1, the other exceeded it, it has to be the middle one. Otherwise, it would be too many cells, blue cells for the column of 1. Now this column is completed. We have both these 2 that are completed already, given their adjacency to blue cells. So we'll mark this as black, and to complete these 2 right here, we have this as blue. Okay, now over to this column right here. Since the blue cells on the 2 with dashes are not consecutive, it means that this cell right here cannot be blue, because if it were blue, it would be 2 consecutive. So that would be illegal for this column. So this is black, making so that these 2 are blue to satisfy both of the 3's. And now this 2 column is complete because it already has 2 blue cells, so the rest of these are black. And now to satisfy both this one and this 2, we need this to be blue. I lied. I didn't pay enough attention. This needs to be black, because the 1 is already satisfied, the 2 is already satisfied. Classic mistake right there. Hands faster than brain. So this is black, and now 1 remaining. 1's left to be colored blue, and done. Okay, so here we have the classic 2 consecutive with 3 cells, so the middle cell has always to be blue. And we have a 2 non-consecutive that has 3 cells. One of these cells is separated by a black cell, so okay, so there are 3 possibilities here. Since there are 3 cells, only one of them is gonna be black. So if this cell was to be black, it still feels weird for some reason. If this cell was to be black, these 2 cells would have to be blue, but that is illegal because this 2 right here requires this to be non-consecutive. So this cell cannot be black. I'm not gonna bother with the other possibilities because they are easy to catch. So this one has to be blue because it can be black, otherwise it would be illegal. Completing this one right here. And now this 2 column needs to be completed. There you go. And this 2 right here. This 2 right here is already completed, so we mark that. This 3 needs to be completed with this. Let's first process this 0 right here. And now let's move on to this one right here. it needs to be completed, and only one adjacent cell can be blue, so that's gonna be that. And now this 2 is completed, so this has to be black. To satisfy this 2, this needs to be blue, satisfying this one, so this is black. This 2 is already completed, so we mark these as black, and to satisfy this column of 2, this has to be blue. What this does is it completes this one right here, and now this one is left over to be completed by this blue. And this 3 is now left over to be completed by this here. That was an overflowing tip because we have this 4 right here that needs 4 consecutive, so if one is at the bottom, the rest have to follow it. And now this 2 is completed, so this is black. Same situation as before, this 3 needs to have 3 consecutives, and if this were to be black, because one of these 2 is going to be blue, one of these 2 is going to be black, given this 3 right here. If this one was to be black and this one was to be blue, we wouldn't be able to complete the consecutive 3 right here. Because this being black means that there cannot be 3 consecutive blues in this column, because we would separate it in 2 sections of 2. So this has to be blue and this has to be black. Now to completely satisfy this 3 right here, we need to have 3 consecutive blues, completing the column and making the rest of it black. This 2 is already completed, so this is black, and this one forces this blue one here to be blue. This 2 also forced that because it had only 2 cells to satisfy it, so this other cell has to be blue. The same is true for this 2 right here, so this cell has to be blue, satisfying this one. Satisfying this one, and now for this 3 right here, we need this to be blue to completely satisfy it. Now this 2 is completed right here, so we mark that as black. And this one comes already satisfied, so we mark that as black. It's the same for this one. The same for this one. And now for this one right here, we need it to be, this to be blue. To satisfy it. Satisfy further this column right here. Now this one requires this to be blue, completing this 2 and leaving it left over to have these 2 cells right here be blue to satisfy both these 3. I think I'm gonna stop here for today because I'm not feeling very good in the throat. I don't think my voice was really fit to be talking in this early in the morning. Oh yeah, I will record another video tonight to see the stark difference between my morning voice and my evening voice. So hopefully I am well at the night. And that's it for today. I think I'll be back soon. Bye bye.